The diagram shows dimensions in meters of an L-shaped garden. The perimeter of the garden is 48 meters. And in the first part of the question, I need to find an expression for y in terms of x. So this is an L-shaped garden and the perimeter of this garden is given to be 48 meters. The perimeter would be the sum of all the outer boundaries of this shape. So the perimeter P would be equal to y plus 4x plus 3y plus x plus 2y plus 3x. So these are all the outer boundaries of this L shape and their sum is equal to the perimeter. The perimeter is given to be 48 meters, so I'll replace this with 48 and 48 is equal to y plus 3y plus 2y is equal to 6y and 4x plus x plus 3x is equal to 8x. In the first part of the question, I need to find an expression for y in terms of x. So I'll make y the subject in this equation and that would give me y is equal to 48 minus 8x divided by 6. I can simplify this equation further by taking 2 common in the numerator and that would give me 24 minus 4x divided by 6. 2 divided by 6 is 1 upon 3. So y is equal to 24 minus 4x divided by 3. This is the answer to the first part. In the second part, it is told that given that the area of the garden is a meter square, show that the area is equal to 48x minus 8x square. So to find the area of this shape, I can divide this shape into two parts. This is the first part and this is the second part. So the total area of this shape is going to be equal to area of the first part plus the area of the second part. The first part is a rectangle and its area would be equal to 4x times y. And the area of the second shape would be the length is x and the height is 2y. So x times 2y. This would be the area of the second shape. So the total area would be equal to 4xy plus 2xy. 4xy plus 2xy is 6xy, so area is equal to 6xy. This is the area of this L shape, but I need to show that the area is given by this equation. And this equation is of area in terms of x only. This equation is in terms of both x and y. So I need to replace y with something in place of x in it. And that we found in part 1. We found an equation for y in terms of x. So I'll replace y with this equation. So the area would be equal to 6x times 24 minus 4x divided by 3. 6 divided by 3 is 2. So the area would be equal to 2x times 24 minus 4x. 2x times 24 would be 48x. So 48x and 2x times minus 4x would be minus 8x squared. And this is what I needed to show. So this is the answer to the second part. In the third part, it is told that given that x can vary, find the maximum area of the garden, showing that this is a maximum value rather than a minimum value. So x is varying and I need to find the maximum area of the garden. So this means that the area has a stationary value. The equation I have is of area in terms of x and it is told that x can vary. So when a has a stationary value, dA upon dx would be equal to 0. So to find the maximum value of area when x is varying, first I'll differentiate this equation with respect to x. So dA upon dx would be equal to 48 minus 16x. At stationary point, dA upon dx would be 0. So 0 is equal to 48 minus 16x. Solving this equation for x would give me x is equal to 48 upon 16, which is equal to 3. So the value of x is 3. This is the value of x when I'll get the maximum area. To find the value of the maximum area, I'll put this value of x in my equation for area. So the maximum area would be equal to 48 times 3 minus 8 times 3 squared. And this comes out to be 135. So the area is equal to 135 meters square. This is the maximum area of the garden. Next, I need to show that this is a maximum value rather than a minimum value. So to show that the nature is a maximum nature rather than a minimum nature, I'll need to take the double derivative. So I'll differentiate this equation again. D square a upon dx square. The double derivative would be equal to 48 is a constant, so its derivative would be 0, and the derivative of minus 16x would be minus 16. This is the double derivative, which is less than 0. And when the double derivative is less than 0, the stationary point is a maximum stationary point. So I've shown that this value of area is a maximum value. This was the answer to the third part of the question.